Good morning, everyone. Myself, Agnisha Bhatta, a student of IT second year, Techno International Newtown. I'm also the team lead of Team Dev Dynamos. We are here with a solution on the problem statement KVH-005, that is Advanced ANPR and FRS solution. Now, KVH-005 states to design and develop a technological solution that can accurately perform automatic number plate recognition, that is ANPR, along with facial recognition from the available CCTV feeds. The solution should be able to recognize number plates that are written in typically non-standard ways using various font styles, sizes, designs, symbols, languages, etc. that is difficult to recognize by existing ANPR systems. Now, the objective of an ANPR system includes enhancing public safety, improving traffic law, enforcing parking regulations, and toll collection. Now, our motivation behind this project is to reduce the problem of highway monitoring, parking management, road accidents, etc. Therefore, let's move on to the solution. Here we have briefed of how we are approaching the solution. For approaching the solution, first and foremost, we need a CCTV footage. Now, a single frame from the CCTV footage is captured and sent to the Google Cloud Vision API. Now, before proceeding, we need to know what Google Cloud Vision API is. Basically, Google Cloud Vision API allows developers to easily integrate vision detection features within applications. Using it would return the green box bounded vehicle images in the frame. Thereafter, image stabilization and calibration is performed to enhance the edges, and the image is once again sent to the Google Cloud Vision API. Therefore, Google Cloud Vision API would provide us with the number plate and the facial images of the driver and the passenger from the image provided. After that, image calibration and stabilization is again performed to get a clear visibility of partially visible and overlapping number plates. The image of the number plate is thereafter enlarged, and age detection is applied for segmenting the alphanumeric characters of the number plate. Once we get the segmented images of each alphanumeric characters of the number plate, we send it to the AWS recognition model. Now, we have designed an optimizing algorithm known as VRNP algorithm, which allows us to optimize the number of searches for recognizing the characters. Using this algorithm, we are finding the characters of the vehicle registration number, and after we get the vehicle registration number, we store the number as well as the facial images of the driver and the passenger as a result in the database. Now we have given a visual representation of how we are performing it. Our first task is vehicle image capture through Google Cloud Vision API. Thereafter, we are performing number plate detection again through Google Cloud Vision API. Thirdly, character differentiation is done through image segmentation, that is edge detection. And our final task is character recognition through AWS recognition model and VRNP algorithm. Now, coming to the technology stack, our project would not be successful without technology stack. Now, coming to the software requirement, we have OpenCV library. Now, OpenCV library is very important since it helps us in frame extraction and image transformation. And green bounding box technique is also called through OpenCV library. Then we have Spider ID for executing our Python programs. Operating system, mostly Windows 10 would be used, and we are using MySQL as a database for storing our data of the vehicle registration number and the facial images. And fifth, we have Yellow V5 that is used as a dataset training purpose. Now, coming to the hardware requirement, we need a CCTV network, processor, and a huge amount of storage for storing the data in a database. Now, as we are talking about VRNP algorithm, we need to know what it is and how it works, or rather, why are we using VRNP algorithm instead of naive searching for the character prediction. After each character is sent to AWS recognition model, our task is to check whether each character is a number on an alphabet. Now, we know that all the state codes are alphabets and all the RTO codes are numbers. Now, first the state codes are checked. That is, if the first character of a state code is entered, and if it is an alphabet, we are checking it. And for in case of India, we know there are 19 alphabets that start as in state codes for India, so we are checking the first letter to those 19 characters instead of 26 alphabets. After getting the first state code, we are referring to the state codes that starting with that letter. Now, what is count? Now, count is basically the number of state codes that start with that letter we have found. In case of in case of W, we have count as 1, since there is only one state code, that is WB, which starts with W. In case of A, the count is 3, since three states AS, AP, and AR are the state codes that start with A. Now, if the count is 1, there is no reason of checking the second letter. That we are directly writing the state code we have referred. If the count is greater than 1, we are matching it to 3 or 4 cases of the second letter, and we are thus obtaining the state code. Now, coming to the RTO code, the first digit of the RTO code is entered. If it is a number, from 0 to 9 it is matched, and after we get the first digit of the RTO code, we are doing the same process. That is, we are checking the count. If the count is greater than 1, all the cases of the RTO codes are matched. And if the count is 1, I mean there is only one RTO code that start with that digit, then directly the RTO code is written. This way, we are getting the state code and the RTO codes. Thereafter, we have the district codes and the unique registration number. Those are also matched through this algorithm, and thus we are finding the entire vehicle registration number using our VRNP algorithm. Now, why are we using this algorithm and what's its uniqueness? First, in this algorithm, we have predefined list for state codes and predefined list for RTO codes. Depending upon these two lists, optimization pattern based searching is done for state code and RTO code. Therefore, it helps us in precise identification of vehicle registration number for any kind of non standardized format. Now, talking about the dependencies, we have Google Cloud Vision API. Each frame of CCTV footage is sent to the Google Cloud Vision API, and thus we are obtaining the image of the vehicle using green box bounding technique. And AWS recognition is also used as a dependency here. Each edge detected object is sent to the AWS recognition, and single mapped characters are returned using VRNP algorithm. Now we have shown standardized and non-standardized number plates. Therefore, it was all about our solution and the algorithm we have designed. Now let's take a quick look on an animation which would help us to get a glimpse of how we are performing our solution using VRNP algorithm.
So now moving on from the PPT. Hello everyone, my name is Omkar Abhishek Jha and I would like to present our idea for the problem statement automatic number plate recognition and face recognition solution through a small video. Starting off, I would like to address the problem statement where we need to develop a technological solution that can accurately perform the automatic number plate recognition and facial recognition. Here, the solution is later defined in the video. Here in this video, we can see a CCTV footage of a traffic crossing signal where a frame of the road comprising of the street lamp, traffic signal, and various cars entry is obtained. Then this frame is passed through Google Cloud Vision API, from which all the images of the vehicle is captured by a green bounding box. Moving on, in this sample video, we would be recognizing the number plate of the red car in the frame whose image from the frame is calibrated and stabilized for better edge detection. Then the vehicle image is again sent through Google Cloud Vision API from where all the images of the number plate and facial data of the rider of the vehicle is obtained. After that, the image of the number plate is enlarged and is undergone segmentation of, through which we get the alphanumeric characters of the number plate one by one. As in this case, we get 2TN as the state code for Tamil Nadu, 12 for the RTO code AF, and 9459. Edge detection is used for the characters for the passing of characters serially. The result of edge detection algorithm is an object boundary with connected curves. AWS recognition is used for the recognition of the characters of the number plate. The algorithm applied by us for the solution of this number plate recognition is firstly the acquisition of image from the CCTV footage, then license number plate extraction and representation of the number plate of the characters of the numbered plate, and lastly the character recognition is done serially. Then the edge detected characters of the number plate, the facial data of the rider of the vehicle, is serially sent through AWS recognition for the recognition of all the data. Lastly, the whole data of the vehicle number and the facial data of the person riding the vehicle is stored in a database.
Thank you for listening to us. This was all about our approach of finding a solution to KVH-005. I would like to thank my teammates Mitul Pramanik from IT second year, Jyoti Anand from CC second year, Loknath Bhuya from IT second year, Devashish Manna from IT second year, and Omkar Abhishek Jha from IT second year for immense hard work and dedication towards completion. I would also like to thank Professor Owen Chakraborty for his immense support and guidance in this process. Thank you.